Dear aspirant, in this module, we are going to see the hypothesis testing in statistical applications. What is hypothesis testing? Hypothesis testing is a formal procedure for investigating our ideas using statistics. It is most often used by scientists to test specific predictions called hypotheses. Hypothesis testing uses data from a sample to draw conclusions about a population. This hypothesis test goes about choosing about two competing propositions called null hypothesis denoted by H0 and alternating hypothesis denoted by H1. In the upcoming slides, we are going to see what is null hypothesis, what is alternative hypothesis, how it is being demonstrated. Statistical hypothesis tests have a probability of making type 1 and type 2 errors. What is type 1 error? Type 1 error rate or significance level is the probability of rejecting the null hypothesis given that it is true. It is denoted by a Greek letter alpha and is also called the alpha level. Usually the significance level is set at 5%, implying that it is acceptable to have a 5% probability of incorrectly rejecting the true null hypothesis. The rate of type 2 error is denoted by a Greek letter beta that is related to the power of test, which is equals to 1 minus beta. This type 1 error and type 2 error we will be seeing in a more detailed way in the upcoming slide. First, we need to understand the hypothesis concept. Hypothesis conceptually similar to the judgment in a court trial. The null hypothesis corresponds to the position of a defendant just as he is presumed to be innocent until proven guilty. So, is the null hypothesis presumed to be true until the data provide convincing evidence against it? The alternative hypothesis corresponds to the position against the defendant. Specifically, the null hypothesis also involves the absence of difference. Thus, the null hypothesis can never be that there is a difference. If the result of the test corresponds with reality, then a correct decision has been made. However, if the result of the test does not correspond with reality, then an error is occurred. So, there is always the probability that the error can occur in the particular hypothesis or particular event which is happening. For example, here the court trial, there is a defendant who can be innocent or who can be guilty. Or there is a possibility that he is truly innocent but proven guilty, or he is truly guilty and proven innocent. So these are the two errors can simultaneously happen. That is called type 1 error and type 2 error. There are two situations in which the decision is wrong. The null hypothesis may be true, whereas we reject H0. On the other hand, the alternative hypothesis H1 may be true, where we do not reject H0. In a hypothesis testing, there are two types of error happen. That is type 1 error, type 2 error. What is type 1 error? The first kind of error is the mistaken rejection of a null hypothesis as a result of the test procedure. This kind of error is called type 1 error, that is false positive, and is sometimes called an error of the first kind. In terms of the courtroom example, what we have previously seen, the type 1 error corresponds to a convicting an innocent defendant. That means we are proving guilty wrongly about the defendant. In another classical example, in a bioequivalent study, test and reference product is being tested and they are not actually bioequivalent, but as a error it is showing bioequivalence. That is called false positive results, and here the type 1 error is happened. Then it comes to the type 2 error. This is the second kind of error, is the mistaken acceptance of a null hypothesis as the result of the test procedure. This sort of error is called type 2 error, that is false negative, and is also referred to an error of the second kind. In terms of courtroom example, a type 2 error corresponds to acquitting a criminal. Means actually he is guilty, but we are unable to prove him is guilty and he is acquitted. In case of bioequivalence example, the test and reference product is actually bioequivalent, but in the study it is showing bioinequivalent, that is false negative. In continuation to the courtroom example, here we are going to see what is the possibility of errors can happen. Null hypothesis HO, the defendant is innocent, and the alternative hypothesis is H1, that is defendant is guilty. All formal decisions are subjected to two types of error, namely alpha, that is type 1 error, beta, that is type 2 error. In this tabulation, if you consider the presumption of innocence rejected, that is considered guilty, there is a possibility of misjudgment, that is a type 1 error. And in case of presumption of innocence accepted, that is you are considering not guilty, then there is a possibility of misjudgment, that is called type 2 error. So all these possibilities would translate into the following decisions. What are the decisions? H0, that is null hypothesis, is rejected, or we fail to reject the null hypothesis, that is H0. So when H0 is true, there is a possibility is that H0 is accepted, but there is a possibility also there can be a type 1 error, that is alpha can happen. And in case of H0 is false, the possibility is that H1 can be accepted, that is the rejection of null hypothesis, and there is a possibility that the type 2 error also can happen. In case of bioequivalence, how the hypothesis is working? There is a two possibilities, that is H0 and H1, that is null hypothesis and the alternative hypothesis. Null hypothesis is product is bioinequivalent, and alternative hypothesis product are bioequivalent. In this case, there is a type 1 error, that is the patient's risk can happen. So when you fail to reject the null hypothesis, the not bioequivalent, the actual correct one can happen, and there is a possibility of false positive results, that is type 1 error can happen, where the product showing bioequivalence wrongly. So that is called patient's risk. And on the other hand, what happened when you consider product or bioequivalent, that is the alternative hypothesis, the correct thing of bioequivalence can happen, but there is a possibility that the product can show bioinequivalent by chance. That is called manufacturer's risk. So during a hypothesis testing, there can be 4 decisions can happen. And out of 4 decisions, 2 can be right. That is, the treatments are in fact equivalent and the study passes. And the treatments are in fact not equivalent and the study fails. And there are 2 other decisions can also happen, that is type 1 error and type 2 error, where the products are in fact equivalent and the study can fail, and the products are in fact not equivalent and the study also passes, that is type 2 error. So when the 2 of them can be wrong, that is the type 1 error and type 2 error, if happens during a hypothesis testing, what we declare in case of equivalence? Although treatments are not equivalent, patients will be treated with a product which possesses the problems. Either the effect will be insufficient or the rate of adverse events not acceptable. There is a 5% chance that this will happen. That is type 1 error. If you fail to show bioequivalence, although the treatments are equivalent, the product will not be approved and the money is lost. That is sponsor risk. The chance that this will happen, that is beta is equal to 1 minus pi, where the pi is the power of the study. That is the type 2 error. Why in bioequivalence null hypothesis is always bioinequivalent? Traditional statistical approach is often designed to test the null hypothesis of equality. If data is sufficiently strong, null hypothesis is rejected and alternative hypothesis is accepted. Before 1980s, most of the bioequivalent studies were conducted by considering H0 is bioequivalent, H1 is bioinequivalence. But researchers tested for differences between drug formulation, and if they found none, they concluded them to be bioequivalent. What are the flaws in this approach? If your sample sizes are large enough, minor differences, even not important clinically, were found to be significant. Whereas if sample size was small, the potential important differences were neglected. Then after 1980, the assumptions were changed based on the following. The purpose of bioequivalence study is generally not to demonstrate a difference, but to assess the equivalence of test product to the reference standard. The method of difference statistics with null hypothesis of no difference is not applicable to BEAD studies. Instead, the equivalence testing with null hypothesis of a difference or non-bioequivalence is used. Hence, after 1980, the B hypothesis was changed as H0 is equal to bioinequivalence and H1 is equal to bioequivalence. This slide showing the formulas which are demonstrating the null hypothesis as well as the alternative hypothesis, and what is sigma L and what is sigma U, which are set by the regulatory agencies. So aspirant, so far we have seen the hypothesis testing, how it is adopted in various scenarios of statistical testing, especially in the bioequivalent studies. What is type 1 error and type 2 error, how it is being assumed to be in the hypothesis testing. Thank you.